Good morning everyone. Now in today's segment we'll discuss about Laplace transform, another important technique from signals and system. Now friends, we know that transform is a technique by which you can convert a signal from time domain to frequency domain. Now what is meant by Laplace transform? What is the necessity of using Laplace transform, that we'll discuss. So basically Laplace transform techniques are used to analyze electrical and electronic circuits. The reason is analysis becomes quite easy. This is the first and foremost reason. And the second one, if you come across Fourier transform of continuous time signal, we generally denote it as x of j omega. So it is applicable only for stable systems. Now if you let us consider that we are having a signal as exponential a raised to 8 into u of t. Now if it is a signal, its magnitude spectrum can be drawn. It is exponentially increasing, so it can be like this. That means your signal approaches to infinity as long as the values are going to be increased. And once it becomes infinite, system becomes unstable. That means to analyze the system which are supposed to be unstable, we need a technique that is called as Laplace transform, and hence it is the most widely used technique in order to analyze continuous time signals or continuous time systems. Now let us see how to find its expression. So for that case, we'll take help of Fourier transform. We are having that equation. Fourier transform of x of t is x j omega with integration e raised to minus j omega t into dt, whereas its inverse Fourier transform equation that I am writing it here will be x of t is equals to 1 upon 2 pi integration x of j omega into e raised to j omega t into d omega. Now next step, we'll replace this j omega by a convergence factor which is sigma plus j omega. This is our equation number first, and let us assume that this is our equation number second. So if I replace j omega by sigma plus j omega in this equation, LHS becomes x of sigma plus j omega is equals to integration x of t as it is into this e raised to j omega becomes e raised to minus sigma plus j omega t into dt. Now this j omega is replaced by sigma plus j omega. So if you see it as a real part as well as imaginary part, so we can write this as S plane, which is nothing but S is equal to sigma plus j omega. So it combines both the terms, or it is also known as complex frequency also. Now if I replace this value, we'll get this equation as xs is equals to integration holds as it is x of t into e raised to this term is minus st into dt. Now this equation is known as Laplace transform of input signal x of t. Basically it has both the limits, negative as well as positive, so this equation we can denote as bilateral Laplace transform. It is also known as bilateral Laplace transform equation. Now we'll come across how to find its inverse Laplace transform. So we'll make the same change in inverse Fourier transform equation. So you can see again we'll try to replace it. So we'll get x of t is equals to 1 upon 2 pi this integration. Now this is sigma plus j omega into e raised to sigma plus j omega t into d omega. Now we'll substitute this sigma plus j omega, that is nothing but s, or replacing it by s. Now further simplification involves here we need a d omega, so we'll try to differentiate on both the side. So differentiating on both the side, we'll get ds is equals to constants differentiation will be 1. This becomes j into d omega. Therefore we can write d omega is nothing but ds by j. Now if you put those values in the above equation, this becomes xt is equals to 1 by 2 pi integration as it is. This term is now x of s into e raised to st. Instead of d omega you can write ds by j. So if Finally we'll get this equation 1 by 2 pi j. This is our integration xs e raised to st into ds. So this equation is known as inverse Laplace transform equation. Now as far as Laplace transform is concerned, we are having bilateral Laplace transform as well as unilateral. So if I consider unilateral, the limit changes from 0 to infinity or minus infinity to 0. So by this way you can find either Laplace transform or inverse Laplace transform. Now we'll come across the second point and the foremost important, that is called as region of convergence. Now this is region of convergence of Laplace transform. So basically a region of convergence is nothing but there are certain values of the variable in the given equation that makes system either stable or unstable. That means they can make the system having magnitude as finite or infinite. So all collection of those values becomes region of convergence. Now this is a Laplace transform, so I am writing this equation. We know that Laplace transform is equals to x of t into e raised to minus st into dt. Now we'll try to replace this s with sigma plus j omega. That means we'll consider s is equals to sigma plus j omega. This equation becomes x of t into e raised to, if I put those values directly, we can write sigma t into e raised to minus j omega t into dt. Now the only change that I am going to make here is we'll write this in a separate term. So this is x of t into e raised to minus sigma t into e raised to minus j omega t. Now we'll compare this equation with Fourier transform equation, and I'm writing it here. We know that Fourier transform is xj omega is equals to integration x of t into e raised to minus j omega t into dt. Now if we compare both these equations, shall we conclude one thing? Laplace transform is Fourier transform of the given equation, or they can be represented in a same form. See it here, Fourier transform is nothing but what? Fourier transform of t is x of j omega, and here the value is what? X of t into e raised to minus sigma t. Therefore we can conclude this term. This is Laplace transform is the Fourier transform of signal x of t into e raised to minus sigma t. X of t, x of j omega, x of t into e raised to minus sigma t becomes x of s. So this is the basic relation between Laplace transform and Fourier transform. And if it is the condition, so the necessary condition becomes this x of t should be absolutely integrable. That means in this case x of t into e raised to minus sigma t should be absolutely integrable. Therefore we can write the necessary condition for the existence becomes integration of x of t into e raised to minus sigma t dt should be less than or equals to infinity. Now this can be possible. See, x of t is input signal, it will be finite definitely. Now exponential term, it entirely depends upon sigma's value. If sigma is having positive values, this becomes less than infinity, and if sigma is negative, minus minus becomes plus. That means the range of sigma or all values of sigma for which this condition can be satisfied, it is simply known as region of convergence. So you can write ROC as all possible values of sigma for which Laplace transform converges is known as region of convergence. So we can draw the region of convergence with respect to these points. Now let us see this example. X of t is equals to e raised to minus sigma t, e raised to minus at into u of t. We have to find its Laplace transform. So we'll write xs is equals to integration x of t e raised to minus st into dt. So this is minus to plus e raised to minus at u of t e to the power minus st into dt. Now this is unit step signal. We know that it will have a value 1 between 0 to plus infinity. We'll make that change 0 to plus infinity e raised to minus at e raised to minus st into dt. Or you can write here also, the reason is what? U of t is 1 for t t greater than or equals to 0 and 0 otherwise. Now the base is same, we can take common from both the terms, s plus a t into dt. Now we'll integrate this, e to the power minus s plus a into t divided by minus s plus a over the limit 0 to plus infinity. This term I am writing as it is. I will put the upper limit of t is infinity with a minus sign, so this becomes e raised to minus infinity, and lower term is 0 minus e raised to 0. Now e raised to minus infinity will definitely be 0, and e raised to 0 is 1, so this is minus 1 into minus, that means x of s becomes 1 upon s plus a. Remember these three values, e to the power 0 is always 1, e raised to minus infinity will be 0, and e raised to plus infinity should be infinite. So we got this Laplace transform. Now the question is, if it is asked to determine region of convergence, now what actually region of convergence is? So we have seen this in case of Z transform, now we'll see in case of Laplace transform. In case of Z transform, we are drawn with respect to a unit circle. Here we have to draw it with respect to a strip which is parallel to j omega axis. Now this is we can call it as a real part of Laplace transform, this is imaginary part of Laplace transform. Now if you see x, this is 1 upon s plus a, so we can have a pole point that makes our system unstable, or it can be infinite. So in that case, first we'll determine the pole point by equating denominator to 0, so we'll get s is equals to minus a. That means if I consider s minus a, this term is going to be infinite. So it exists everywhere. We can say that Laplace transform exists everywhere except at what? S is equals to minus a. And the foremost important thing is whether our signal is right sided or left sided. So the signal is multiplied with u of 2, that means it is right sided signal. And if it is a right sided signal, always remember ROC should be greater than the pole point. That means in this case we can write ROC is greater than, this is minus a. So we'll draw it. This is minus a, that means it will be here. So we'll draw it. This is the strip. This is minus a, and this becomes our region of convergence. That is ROC is greater than minus a. Now this is the case when the signal is right sided. Now if the signal is left sided, definitely ROC will be less than the pole point, and if it is both sided, it will be greater than and less than the pole point. Now let us consider this example. We have to find its Laplace, so we'll put those values directly. This is minus e raised to minus at u minus t e raised to minus st into dt. Now the signal is multiplied with u of minus t. U of minus t is nothing but time reversal of u of t. So you can write u of minus t will have an amplitude 1 for the value of t less than or equals to 0, and otherwise it is 0, so it is going to be a left sided one. So we can make that change. So I can write now this limit from minus infinity to 0. This minus I am taking outside. This is e raised to minus at into 1 e raised to minus st dt. So by that we can write minus as it is, minus infinity to 0, base is same. We can take minus sign as well as t as common, and we'll integrate this. So its integration we can write e raised to minus s plus a into t divided by minus s plus a, limits minus infinity to 0. We'll put those limit. This minus and minus will get cancelled. Upper limit is e raised to 0. Lower limit is e raised to minus infinity upon s plus a. Now if you see, this t is minus, so don't make minus into minus plus, otherwise it approaches to infinity. It should be minus infinity only. So by that case, e raised to 0 is going to be 1, and e raised to minus infinity is 0. So we'll get Laplace transform as 1 upon s plus a. If you see, in both the cases the Laplace transform is same. Here also 1 upon s plus a, here also 1 upon s plus a. Only the difference is region of convergence. Now here it is multiplied with u of minus t, that means it is a left sided sequence or signal, sorry. So ROC should be less than the pole point. again the pole point is minus a. If I draw the region of convergence, this is again real part and this is the imaginary. We can write sigma and j omega also one at the same. Pole point is minus a, so we will draw a pole point here, a strip with minus a. Now it should be less than minus a, that means this becomes R region of convergence, that is ROC should be less than minus a. So in the first case it is greater than minus a, and in this case it is less than minus a. Remember here ROC should be drawn with the reference to the pole point, that means it doesn't contains or doesn't include the pole point, otherwise it becomes infinite. Now the next example is, we'll see for both sided signals. You can see this x of t is a combination of e raised to that exponential with u of t, exponential with u of minus 2. So this signal is right sided and this is going to be left sided. So we'll write directly their Laplace transform. We have seen this. Laplace of e raised to minus at into u of t is 1 upon s plus a, whereas for this Laplace of minus e raised to minus pt into u of minus t is 1 upon s plus b. And the only difference is this is right sided, so it's ROC. We can write it is greater than minus a, that is the pole point, and in this case the ROC will be less than minus b. Now we'll try to write the entire Laplace transform, which is addition of 1 by s plus a plus 1 upon s plus b. If you want to simplify, you just cross multiply it, you will get this simplification also. Now we'll come across combined region of convergence. Now the condition is what? It should be greater than minus a, at the same time it should be less than minus b. Now we'll draw its region of convergence. This is their sigma and j omega. Now we'll plot the two pole points, one is minus a, one is minus b. So let us consider this is minus a, and let here I am placing minus b. Now the condition, ROC should be greater than minus a, so we'll draw region of convergence with reference to that. It should be greater than minus a, which can be up to infinity, and at the same time it should be less than minus b. That means both these conditions should be satisfied, so we'll draw a strip parallel to minus b also. Now the condition is what? It should be less than minus b. Less than minus b, that means we can get a overlapped region between minus a to minus b, so this becomes its ROC. Condition is what? It should be greater than minus a and it should be less than minus b. So this is for both sided signal. In university examinations, only the values are going to be changed. Instead of a, they will get some different values, instead of b, they will take some different values. Remaining terms or approach is going to be same. Thank you.